Okay, hello everyone. This is just an additional video for showing you some exercise that I think you guys need more exercise. So let's start uh, with the first questions. Okay, let's start from this is about the chapter 3. Okay, chapter 3 exercise. Okay, the first question: find the third derivative of y equal x ln x. So you need to find y, not 2 but third. Okay, so you can stop the video and try first by yourself and then compare the results with me. Okay, let's start. So first we are going to derive this, and we are going to see that this is our product rule. So y prime, the first derivative will be ln x plus x over x, or we can say that this is 1 plus ln x. Okay, if we are having second derivative, this will be 0 plus 1 over x, or this is just 1 over x directly. And the third derivative, we have just derived the 1 over x, which is negative x, or this is the answer. Okay, do you guys get correct? I think this is the first one is quite easy, right? Okay, now move to the next one. Okay, let's go to the next page. Okay, let's say we have functions g. This is ln and x squared minus 1. What will be the first derivative of g? Pause the video and try by yourself, and we can compare the results later. Okay, let's start. Now if you have a function of ln x, you know that this will be 1 over x, or if you have y equal ln 2x, this will be resulting 1 over 2x and then multiply with 2. Or if you have y equal ln and then x squared plus 1, okay, this will be resulting with 1 over x squared plus 1 and then multiply with the chain rule 2x. Okay, same thing we can do in the ln here. So g prime will be 1 over the whole inside function and then derive the inside function with the chain rule, right? Okay, so to finish this, to get the result, let me write here, and then we can see that this is our product rule. So we will have square root of x squared minus 1 plus x, and then this will be 2 squared minus 1, and this will be 2x. And we can cancel this, and we have or let's just multiply directly. Okay, I will just multiply directly here. Multiply, and then this will be 1 over x plus cancel out there, so it will be plus x squared x squared minus 1. Okay, or we can just see that this is x over x squared minus 1. We can simplify. plus x squared. And this will be resulting with 2x squared minus 1 x squared minus 1. I think this is it. Or you want to make it into like this, it's okay. I will make it into this one. This will be the final results. Okay, it seems that I write the steps. I think it's too long, right? It's too long. Okay, I think we can make it short. So if we look at the question again, let me write one more time. This is ln x plus, right? Okay. Oh, right, wait, not x plus, sorry. X squared of, okay, that is the question. Now, because this is an ln, we can use the log law. Ln of x plus ln of square root of x squared minus 1. Okay, if you remember, this came from log AB, and this will be log A plus log B. Okay, we have maybe another one is A over B. This will be log A minus log B. Okay, now let's continue to the question here. So g prime x, this will be 1 over x plus 1 over this, and then multiply with 2x. Okay, or even let's see from here. I forgot to mention something. We can write this as, and by the log law, we can also write, and it's make our life easier. So g prime x will be 1 over x plus half 1 over x squared minus 1. This will be 2x. So we will have x squared minus 1, x squared minus 1 plus x squared. So this will be 2x squared minus 1, x squared minus 1, which is the same answer as the previous one here. And I prefer this way because it's much easier when you derive. Okay? So this part here, we are just simplifying our steps. That's just an algebra. The calculus part is starting from here, right? But the first case here, you directly do the calculus. Okay? You directly do the calculus. Either way, both methods correct. Okay, so you can choose which one you prefer and solve the equations. Okay. Okay. Let's go to the next question. Okay, let me go through the question. At what points on the ellipse okay, is the tangent line at that point parallel to the line y equal negative 2x plus 6. You can stop the video, pause the video, try calculate this question by yourself, and then later we can compare the results. Okay. Okay, are you ready? Okay, let's start to finish the question. Okay, let's start to find the answer. Okay, let's start with the curve. We have curve 3x squared plus y squared equal 21 because it's related to the tangent line. So what we can do is we are going to directly differentiate this curve and using the implicit differentiation. Okay, we can differentiate 6x, okay, for 3x squared, and then plus 2y. Don't forget dy over dx, and equal 0. And we can simplify this and make it become negative 3x over y, right? Now we have the line is this line, okay? This having slope of negative 2. And because it's parallel, we have the same slope. Okay, we have the same slope. So this should be equal with negative 2. Okay, or we can write the simplify this and make it 3x is 2y, or y will be 3 over 2x. Okay, and then how do we solve this? We have the ellipse, okay, because it's asking points on ellipse. So we are going to substitute this y or x, if you, it depends on which one you prefer, to the ellipse. So we have an ellipse, 3x squared plus y squared equal 21. So 3x squared plus 3 over 2x and then squared equal 21. So this will be 3x squared plus 9 over 4x squared equal 21. So solving this, and this will be 21 over 4x squared equal 21. So x squared is 4, so x will be plus minus 2. And y will be plus minus 3. Okay, so the point will be 2 and 3, and negative 2 and negative 3, and that will be our answer. So you need to answer until this point here. Okay, if you just finish maybe just finding the here, it's not finished yet, right? Okay, let's move on. Another question that I have in mind is about the inverse of trigonometry. Okay, so we have y, sine, and then tangent inverse x. Okay, so it's asking about the y prime. Okay, how to solve this? First, we can directly goes by cosine and then tangent inverse x and then d dx of tangent inverse x and solve that, right? So cos tangent inverse, how do we deal with this? First, we can take this let tangent inverse x as theta. Okay, so we will have our y is or our tangent theta is x. Okay, and I'm suggesting always using this triangle here to get the idea of the inverse. Okay, so this is theta, this is x, this is 1, right? And this should be x squared plus 1. So basically, we are going to look at cos theta, which is 1 over squared, okay, x squared plus 1. So this will be 1 squared of x squared plus 1. And d dx of tangent inverse will be 1 plus x squared. Or if you want to simplify this, we can have this at square root of 1 plus x squared and then 3, okay? Because you have 1 plus x squared, half, and then 1 plus x squared. So 1 plus half is 3 over 2. So 3 over 2 becomes this 1 over square root 1 plus x squared cubed. Okay, then this will be the answer. Do you get the same results? Okay. Okay. If not, then we still have time for practice. Okay, next question. Next question. Okay, if I have a function that is 5 to the power of sine x, what will be the f prime x? Okay, this is a chain rule, right? Of course. So we're going to see 5 with power of x, and we are going to have a sine x. Okay, so we combine these two functions here. So f prime x will be 5 sine x, and then ln 5, and then we need to have the chain rule of sine x will be the cos x. Okay, we can go directly like this, or if you want to write like in y 5 sine x, we can add ln if you want. Maybe you feel that this terms is difficult to follow. If you have the exponent like that, then we can have ln, and then we can have ny. Then we can take this down here, sine x ln 5, right? And then we can do the implicit, and we can have 1 over y, don't forget the 1 over the x, and then sine x becomes cos x, sorry, and ln 5, and dy dx will be, y will be going to here, and y is 5 with power of sine x, cos x ln 5, which is the same result with our solution here. Both method correct. Which one you like, you can choose. Okay, maybe last questions for the practice. Have y ln secant x plus tangent x. It's asking the y double prime. Okay, so first we can do the, you can stop the video first, try your best and look at the result. Is it the same as me or not? We take the ln secant x plus tangent x. Okay, we take the first one, okay, the first derivative, and we take this as 1 over secant x plus tangent x, and then we can simply derive the inside. This will be secant will have secant x tangent x, right? And the tangent will have secant squared x. Okay. Now what we need to do to simplify this? Okay, we can simplify by my way. Okay, I prefer to change all the secant and tangent into sine and cos, because that is more reasonable, and I do recognize sine and cos better than secant and tangent. But it's up to you which way you want to simplify this equation here. So this will be 1 over cos plus sine x over cos x, or I can simply say that this will be, the whole thing here will be 1 plus sine x over cos x. Okay, and here this will be 1 over cos x sine x over cos, or I can simply write this in cos squared x, and this is so sine x over cos squared x, plus 1 over cos squared x. Okay. Now from here, we can write this, and we can simply see that we can have a nice cancellations. Okay, so this will be 1 over cos x, or this is a secant. So when you get the second derivative of secant x, this will be secant x tangent x. Okay, and that will be the answer. Okay, I think this will be the last one. So I will make another video if you need to have more exercise. But I think for this video now, I will stop here, and hopefully this can help you for practicing the calculus, especially chapter 3. Okay.